Let's take a look at homework. Okay, I wanted to work through it because I know some of you are struggling with it. Um, so again, when it has F at or G at or H at, H with parentheses, G or F with parentheses, whatever, that means you're going to substitute in for the variable. Okay, so this is saying that the function at x is equal to that. So I'm going to take 4 and plug it in for my x value. There was an x here. It's now going to be a 4. Order of operations takes place, so exponent first. And then 2 times 16 is 32, minus that is 27. Okay? I'm going to plug -5 in for x now. So again, there was an x there. Now it's going to be a -5. What's -5 squared? 25. So 2 times 25 is 50, minus 5 is 45. Okay? F at 0. So I'm going to plug 0 in for x. There was an x there originally. Now it's going to be 0. So 0 squared, 0. 2 times 0 is 0. Minus 5 just comes up to -5. And then plugging 10 in. Again, there was an x there originally. I'm now going to put a 10 there. 10 squared is 100, times 2 is 200. 200 minus 5 is 195. Okay? So again, you're substituting in the value that's given. If I gave you f at smiley face, you'd plug a smiley face in for wherever you have the variable. If I gave you f at m, you would put m in wherever you had your variable, and so on and so forth. Okay? Down here at bottom one, I'm going to plug -4 in, so this gives me 2 times t. Some of you got confused because it was a t. It's just another variable. So now I'm going to plug -4 in. Okay? 2 times -4 is -8, minus 3, so I get -11. On this one, I'll plug half in, so I get 2 times half minus 3. Oops, that's a 3. 2 times half is 1. 1 minus 3 is equal to -2. Plugging 0 in, it's 2 times 0 minus 3. So that gives me -3. Plug 8 in, 2 times 8 minus 3. So that's 16 minus 3. That's equal to 13. One other thing I wanted to point out to you all. This yields me the point 4, 27, okay, which is a point on the graph. This yields me the point -5, is that 45? This gives me the point 0, -5, and this gives me the point 10, 195. Okay, this gives me the point -4, -11. This gives me the point 1/2, -2. This gives me the point 0, -3. This gives me the point 8, 13. Is that all okay? Okay, so we started out, you're plugging in for your variable when you have it in functional notation. But then number 9, we want to find what t is when g at t is equal to -1. So here, this means I'm going to set this equal to that variable. So I'm going to get -1 equals 2t minus 3. And that's just second week of Algebra 1 to solve. Add 3 to both sides. Divide by 2. So t is equal to 1. Okay? So this yields me the point 1, -1. Why did this -1 go in for the y value versus the x value? It's not in the parentheses. It's the output that it's given. Okay? So here's your output here. So 17 is going to go right here again. So now I'm going to go 17 equals 2t minus 3. I'm going to add 3, divide by 2. So that's going to give me, what, t is equal to 10. So that gives me what point? 10, 17. Okay. What am I going to do on this number 11? 13 equals what? 2t minus 3. Again, we're going to solve it. Crystal, how am I going to solve that? You are choosing to sit in the back and you can't see it? Again, I'm going to rephrase my question. You're choosing to sit in the back. It's open seating anytime you want. And you're choosing to sit in the back. You can't see my board? Let's make a little bit better choice. What might be a better choice? I'll let you. Go ahead. Go where you need to. I don't know. No shame. I'm just, you can't see something, move up.
I still can't see. Maybe you should get glasses.
You're sitting in time.
You're always welcome to sit on the floor if you want. Is that seat right there better? Can you see it more directly?
We're going up to the board.
No,
We're going up to the board for a second to read it.
You want to sit in the desk that's being recorded? You want to sit in this chair? It's kind of a goofy chair, which you're welcome to.
Try these.
All right.
It's so embarrassing.
Well, if you can't, do you normally wear glasses and you just forgot them today, or wear contacts, or
We're just shunning you on purpose.
you wear contacts, but you didn't wear them today? Do you normally wear them to school? Okay, just today it was a fluke day, huh?
No, she.
TJ, I'm talking to her. Crazy. She's gonna start playing with matches here in a second. All right, add 3 to both sides. Divide each side by 2, so I get t is equal to -5. What point does this yield me? What point does that last one yield me? What is it? Almost.
Wait, -5, -15.
There you go. So remember, on those ones, it's giving you the output. The output's the y component, and you're trying to find the input. Are there any of those that you need to go over on questions? Are we okay? What'd I do?
Nothing, I'm fine.
Oh, okay. Just talking crazy. It happens. All right, can I clear these? I hope so. TJ, you're just turning into a mean kid, man. I tell ya. You're one of my favorites. Now you're just getting all mean and mad. All right. So 15, 16, 17, 18. I'm plugging 2 in for W. I'm plugging 0 in for W. I'm plugging -1 in for W. And I'm plugging 3 in for W. Correct? So let's just do this real quick. Because I'm plugging 2 in, I'm going to get 2. That's gives me 6 times 2, which is 12. What? What? Yeah, real funny there, mister. All right, plug 0 in for W. 3 times 0 times 2, 0, 0. Plug -1 in for W. -6, right? Plug 3 in for W. Okay? Now, these next ones, notice what I did above. I made a point out of those. So what point is this right here?
6,
1, 6. Okay, remember, this is the input, which is the x. What point is this one? -3, -10. And then I'm going to use the slope equation. You need to know this, guys and girls. So x1, y1, x2, y2. So I'm going to get -10 plus 6 equals -3 minus 1. -10 plus 6 is -4.
Why do you add 6?
Oh, because it was negative, negative. Oh, wait. You're right. Wait. -10. Thank you.
That's why I was asking.
Thank you. You're awesome. That's it right there. -16, and that gives me +4. Ooh. Thank you. I'm sorry. All right. What point does this yield me? 0, 1, -1, and this gives me what? 3, 5. Again, x1, y1, x2, y2, using the slope equation. 5 minus minus 1 is 5 plus 1. 3 minus 0. So that's 6 over 3, which is 2. Is that right? So input, output, x comma y. Input, I. So things to think about is this. Okay, XY alphabetical, DR alphabetical, IO alphabetical, right? And then I have F and then more to it. So, huh? It's like the one thing in math that like kind of goes along with going, well, duh. And I discovered that like 3 years ago. It was like my 17th year teaching. I'm like, oh, look how cool it is. Yeah. I-O, right? And if you don't know your alphabet, I'm sorry, but I'm not going to post the alphabet above the board.
Oh, shoot.
I know.
Was it the bottom one? Was it?
Can you do like the thing that third grade teachers do, like the little alphabet thing that goes along your room?
Yeah. A is for apple, B is for baseball.
No, it's like
C is
letters all around.
car.
Yeah,
No,
it's like that thread that goes along the.
You could be good at something, what?
My English is special. Your time.
All right. Hey, domain goes with which value, x or y? X. Okay, so let me ask you this. If I'm traveling along the x-axis, I'm traveling along the x-axis, so to the right and to the left, is the graph existing both above and below at all points in time? Everyone okay with that? So the domain of our graph goes from negative infinity to positive infinity. Now I want you to think about the range. The range covers the y direction in both ways. Does the graph continue all the way up forever? Does our graph continue up forever? Yes. Does it continue down forever?
No.
No.
No. There's a point
Oh,
where
no.
it stops and then goes back up.
So we have like right here, we have it's changing directions. It's either going down to go up or going up to go down. So right here, this is our x-axis, which is at 0. So our range, being it touches it, is going to go from 0 to infinity. Okay? Why did I use a square bracket and not a rounded bracket with 0? Does our graph touch the x-axis? The x-axis is acting like the floor, so it goes bounce and comes back up. Does it touch it?
No.
If the x-axis is my floor,
Yes.
and if I were to take a ball and bounce it, would the ball touch the floor? It does. So do we include the floor as part of the graph?
Yes.
Yes. So that's why we have it as a square bracket. Give the intervals where it is increasing. Give the intervals where the graph itself is increasing. Okay? So, as I'm traveling this way, am I getting smaller values? Okay? As I get over here, do the values start getting larger? So if you were to come to the left to the right, it was decreasing from a certain point, but then right about here, it's going to start increasing. So it's going to start increasing, and I'm going to make this a rounded bracket from 0 to infinity. Okay? Why do you think it's a rounded bracket at 0 and not a square bracket like the domain? This is a little bit further beyond math. Why do you think? Thanks to, let's use the tennis ball and the floor. So the tennis ball hits the floor, comes back up, yes? If the tennis ball is just sitting on the floor, is it going up or down? Neither. It's neutral. It's actually horizontal to the floor. It's horizontal to the floor. It's forming a perpendicular kiss with the floor. So that's why it's a rounded bracket. Okay? Kiss it. Okay, and where would the intervals on the y-axis where the function is positive? Ooh. Where is it positive? So positive means it's above this line. It's above the x-axis. So are all these values over here positive? Are they all positive over here? Meaning, what are my y values? My y values are all positive. They're all positive. What's my y value down here? 0. Is 0 positive or negative? Go with it. You know it. It's 0. It's not positive or negative. So where is the function positive? It's positive from negative infinity all the way to 0. And from where? Where's it going to start back up? It's going to start at 0. And why don't I go just negative to positive infinity? What's taking place at 0? Actually, it's not 0. I can't even see my graph anymore. Let me erase this. Let me erase so I can see this. I'm sorry, I thought it was. So what is that value right there? 2. So this goes up to 2. And this goes to 2. Okay? So at this value here, at this 2, it was all positive up to this point. Gets to here, gets to 0. That's not positive or negative. And then from here on, it goes back to being positive. Where is it increasing? It's increasing right here, just on this little portion right here. So that's why the increasing takes place. It's coming downward, taking place. And so the characteristic that falls with this actually is a pretty high-level calculus concept dealing with tangent lines. Okay? Are we A-okay? All right. Can I do a little lecture? Are you okay? And the nice thing is, it's only a small assignment size, 3 questions.
Oh, whoa.
I know most of you guys are going to cry yourself to sleep on that.
Oh my God.
That is a lie. That is an evil, evil lie.
That is
Look at it. That is not.
A, B, C, A, B,
There's
C,
3
D,
questions
E,
for
F,
ABC.
Oh, I'm sorry.
We have to learn
That was a
A,
lie. So you're a liar who lies.
You're a liar.
Sorry.
You are a liar who
I'm
lies.
a parent. I have to fit the kids at some point.
Well, you know, like, you're just like, okay, guys, you only have 3 problems tonight, and each of those problems has 25 questions attached to them.
Has the whole alphabet of questions.
There's 26 letters in the alphabet.
It's like that one vine.
All right. So, all right, I won't lie to you anymore. So, if you have your homework, if you have that booklet, get it out.
He's gonna do the first line with us.
Oh, really?
All right. So, this is the equation. Agree? Agree? So you should have your notebook out. You still with me? So that's roughly what it is. I mean, I wasn't as artistic. For what values of x? So what values of x is y greater than 4? Okay, so think about this. Which one of those is the y-axis? The one that goes right and left or the one that goes up and down? up and down. This is my y-axis. Everyone agree? This is the x-axis, just for those of you who aren't following along as closely. Okay? So what values are needed to be plugged in where my y is larger than 4? So is my y larger than 4 here?
No.
No, this is the point what? This is the point like 6 comma 0. Do you agree with that?
Yes.
Is my y greater than 4 right there?
No.
No. Let's take a look right here. What is this point?
3.
What's the point?
3.
Oh,
0, 3.
0, 3. Is my y value bigger than 4 at that point?
No.
No. I gotta look at my graph. So it looks like right 2. So if I were to go up 1 and left 2, okay? So that is the point. What point is this right here, and how did I get there? What point do you think that is?
Negative 2, 4.
Negative 2 what?
4.
Negative 2, 4. Okay, now how did I just get there? How did I know that? And if you're looking at your graph right now, it's not probably as clear as mine, or mine is pretty dingy. How did I get to that point? Negative 2, 4. What? Good. But, so what's my slope of this line that's up here right now? What?
Oh, wait.
Negative 1/2? So, negative 1/2. That means I got to go down and right. But I didn't go down and right to get to that point. I did what? Up and left. So down is negative, right is positive. Up is positive, left is negative. So you remember that term that I had said, is this going to be the same thing? So watch this. If I went down and right 2, I get here. If I go up 1 and left 2, I get to right here. That's how I got to that point. I knew this point was 0, 3. So if I go up 1 from that, I get to 4. If I go left 2 from 0, I get to negative 2. So where is my graph, by using the points that are up there right now, where does my graph become a greater value than 4 in the y direction?
Nowhere.
Not here, agree? Because that's continuing downward. That's not here, right? What about here?
Negative 4, 5.
That arrow means it's going forever. Do you agree?
Yeah.
So being it's going forever up there, this isn't going to start changing directions as I get out there. So from here to the left, it's going to be a larger value than 4. So this is going to be larger than 4, starting at negative 2 and going to negative infinity. Now that's kind of nasty how they've written that, so you have to realize you should flip-flop it to give this as your answer. So from negative infinity, way over here in the x direction, that graph is way the heck up there. It's way bigger than 4. As I come closer and closer and closer to negative 2, I still am above 4. Okay? When I get to this point, what am I exactly at? I'm at, in the y component, at 4. Do I want it equal to 4? No, so I'm going to use a parenthesis to express that we're going to get really close, that x value to be negative 2, and that's still going to yield me a value that is bigger than 4. What are the values of x if y is between 1 and 4? What are the values of x So what are we looking for? We're looking for x. What is the 1 and 4 representing? Y values. Okay? So, I'm going to look on my graph. I'm going to say, okay, I want these to be y values. So, 2, 3, 4. So in between these 2 points, so I want to know, if I come over this way, what is that x value? And then if I come here, what is that x value? And if I come to right here, what is that x value? If I come to here,
Still zero.
okay, so think about this. This is what's taking place. This is going to look a little silly. Okay, so between 1 and 4. How would we even solve this? If our graph isn't exact, how would I solve this? Which value is this? It's 1. For what value? X or y? And y goes with which component? Up there. Is this is the y value. Is that the same thing as f at x?
No.
F at x and y are the exact same thing. If I take 1 and plug it in, still with me?
Oh, I get it.
Subtract 3, I get what? Multiply each side by negative 2. Negative 2 squeeze in there. Okay, so that's 4 is equal to x. So 4 comma 1. Plug 2 in to f at x. Subtract 1 or 3. Multiply by negative 2. So that gives me 2. Plug 3 in for x, or function at x. Subtract 3, that's 0. Equals negative 1 half x. So x equals 0. Plug 4 in. Running out of space. 4 equals 3 minus 1 half x. So, what values of x, if what are the values of x if y is between 1 and 4? Okay, now does it include the decimals and everything else in between those? So what's my smallest x value that's up there? Negative 2. Close parenthesis. What's my largest? Parenthesis. So my answer to this answer, values of x if y is between 1 and 4. My values of x are between negative 2 and 4. And if it's in between is not including it. Okay? And then the easiest question, but they have it last. What is the domain of this line? If I go to negative infinity, which is as far as that way as you can go, is there still going to be a graph above it or below it? It's going to be one of the two. Do you agree? What if I go this way forever? Is the graph going to be above or below the line as well? It's going to be below, right? And it's going to keep going. So is there any breaks in my line? No. So my domain of this goes from negative infinity to positive infinity. It doesn't stop. It doesn't change directions. It exists continuously both ways. Can I do number 2?
Yes.
Okay. For those of you who didn't copy down number 1, Good thing I'm recording. You just watch the video. Can I clear this? All right. So I have a parabola. It's looks something kind of like that. So my equation, they're using g at x. G at x is the same as what letter? G at x is the same as what letter? Huh? Is this and this the same thing? Yes. So what is g at x the same thing as? Y equals. Okay? So functional notation and just standard notation. Okay. So we have a parabola. It's comes down, bounces, goes up. So let's answer letter A. Where is g at x? What values for x is greater than 9? Okay. G at x. G at x is the same thing as what? Y. Okay, g at x is the same thing as y. So, let's say 9 is right here in the y direction. So right here and right here, both of those give me x values. On either side of that, they're going to have values that are bigger than 9. Can I say that? So where it's green up there, that's yielding me a value for y, or g at x, which is the same thing, which is larger than 9. So, where am I plugging that 9 in? G at x is the same thing as what? Y. 9 is the same thing, so I'm going to go 9 is equal to x squared. Still with me?
Yes.
What did we learn in the last unit that we could do to both sides? Square root. If I do the square root, if I do the principal square root, this is going to have both positive and negative components. Okay, so I get x is equal to plus or negative 3. So, at 1, 2, 3, and at negative 1, negative 2, negative 3, my y values on either side of that. So if I go this way, in the x direction, so if I plug 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, etc. in for my x value, it's going to give me a y value that's bigger than 9. Also the same as over here. At negative 3, if I go negative 4, negative 5, negative 6, negative 7, so on forever and ever that way, you're still going to get a value bigger than 9. Okay? So, to answer this question, from negative infinity to negative 3, and from 3 to infinity, those are going to give me y values that are bigger than 9. What kind of values are going to happen in between? Are the values still bigger than 9? So are the values in here bigger than 9? No, they're less than 9. So we've answered the question. Where are values bigger than 9? What regions? Well, from negative infinity all the way to negative 3, not including negative 3. And from 3 to infinity, we have a region that's bigger than 9. Does that make sense? Letter B. Find the values of y when we're here. Okay, let's take a look at B. I want to go from here to here. This is all we're talking about for this problem. So those are x values. If this is my equation, what's going to happen? Y equals x squared, right? or f or g at x equals that. So if I plug 1 in, if I plug 2 in, if I plug 3 in, I get 1, I get 4, I get 9. Okay? So what are my y values? And we're including equal to. I'm going to go from square bracket 1 to square bracket what? 9. Okay? Why are they square brackets? What indicates up here we're going to use a square bracket? These equal signs here and here indicate I have to use it as a square bracket. We're including the endpoint. So what are my values? Between 1 and 3 on the x, that'll give me my y value. My values between those 2 points are going to go from 1 to 9. They're going to have 1.1, 1.2, 1.3, 1 point whatever decimal, all the way up to 8.9 repeating forever and including 9. So that's letter B. Little different math to think about. Find the values of y that correspond when x is bigger than 2. Find the value of y when x is greater than 2. So we're talking here, which goes here. And I want, that's going to be an open dot going up. So I'm going to take that x, I'm going to plug it into my original equation for x squared. So 2 squared is? 2 squared is? 2 squared is? 4. So 4 to infinity. Why is it not a square bracket? There's not an equal sign there. So if x is greater than 2, what's my y going to do? It's going to go from 4 to infinity. It's not going to include 4 because we didn't want to add it as a starting point. That's your answer to letter C.
Wait, what is it?
4 comma infinity. My y values will go from 4 to infinity, not including 4, so it's a rounded bracket. Domain. If I'm cruising along the x-axis and I look up or down, do I see the graph at all points? If I'm cruising along the x-axis, if I'm coming along from negative infinity, way out here, can I look up and still see a graph?
Yes.
If I keep coming, do I still see a graph looking up or down?
Yes.
Still see a graph, still see a graph, still see a graph, still see a graph? What's my domain? There you go. My domain is going to be from negative infinity to positive infinity. So I was traveling along the x-axis. What about my range? Think of the range as an elevator. Does the elevator go to the ground floor or does it go below the ground floor? It goes to the ground floor. Ground floor is known as what? 0. So my range, does it touch here?
Yes.
So it's a square bracket.
Would that be 0 too?
And on what values of x is g at x increasing? So this is coming down, all down, all up. Where am I increasing? Where is this increasing? If this is coming all down to here, and this is going all up, where am I increasing? 0 to what? Infinity. Okay? Rounded bracket though. Why is that? Because if it's sitting on the ground floor, it's not going up nor down. That's where it's rounded. So all for your homework I want you to complete is problem number 3. Though there are 5 parts to it, I think you have enough knowledge of how we just went through this. Cool? There is a quiz on Monday. I think you're going to do great with it.
Wait, it's on a Monday quiz. It should be like 2 days.
Nah.
You'll do